Okay, good afternoon. We will so today I am taking this class. This is actually lot of pattern recognition. Anish sir will be taking one of my classes on another day. So we had seen the congestion control, how it is implemented in TCP. So basically, it depends on setting a threshold value for the window and varying the window. So you have window size increasing here, and then it increases up to some time exponentially up to some value. Then we set this value. After that, it increases linearly. So this is slow start, exponential increase. This is additive increase. Then there is a multiplicative decrease when an event like timeout or 3 ACK comes. After this multiplicative decrease, if the event is timeout, again this window will increase from 1. For this window will start increasing from this half this value. So that is what we had seen uh, in the morning. TCP, how it uh, manages congestion in the network. So that is basically by having a window size, varying the window size. Okay, this is the window size variation for the slow start phase. It increases rapidly, then it increases linearly. That's how this congestion is controlled in TCP. Now we will come to quality of service. So basically in networking, the service which the network provide is reliably we should transport the packets to the destination. Again, here this is term is quality of service. So here initially itself it has been written that is discussed more than defined. So in physical networking, how to what extent quality of service is implemented is another question. However, we need to provision for this quality of service. What are the techniques to provide for the quality of service? So we can informally define quality of service as something a flow seeks to attain. Flow means a flow of packets. So there could be say different types of customers. Some customers are willing to pay more for their desired quality. So it could be that they want load less delay, or they want more throughput, or jitter, or there are many metrics for defining the quality with regards to transferring packets from the source to destination. So what are the characteristics of the flow? Flow of packets. So the characteristics of the flow should be reliable. So it should have minimum delay. And jitter. Jitter is another characteristic. And the bandwidth. This is obvious. Bandwidth being one. So reliability means losing packets or ACK, whatever it is, they return ACK. We should go for retransmission. So that is how we built in reliability with the timers, with the sequence number, with for packets and ACK and retransmission. So here, like for an email or a file transfer, suppose you have a financial transaction across the net. The same thing, it's going to the packet. Now you don't want the values to change or something like that. So this is a must. Reliability is a must. So for certain application, reliability is a must. Okay. So for an internet access through telephony or audio conferencing, we don't require that level of reliability. So it depends on the application. So reliability is must for certain applications, mainly banking, transaction, all these things. Now delay. So telephony, audio conferencing, video conferencing, remote login, all these, they need minimum delay. Whereas for an email or file transfer, it need not be that important. So, so it depends on the application. So in quality of service, these are the four characteristics of the flow: reliability, delay, jitter, bandwidth. So it depends on the application, what quality of service you are expecting. So it should be provided by the network. So something should be implemented in the network to provide the quality of service. Now jitter. Jitter means when you have many frames are arriving, if the delay for packets belonging to the same flow has varying amounts of delay, then the frames you receive first frame, then between second frame, third frame, etc. The delay, if it is varying, it is called jitter. So for audio and video application, it does not matter if the packet arrived with a long delay, as long as the delay is same for all packets. So the first packet it gets after, say, not a millisecond delay, after a second delay, a few seconds of delay, but then after that each frame you should keep on getting at regular delays, at regular intervals. So there should not be variation. So we are actually uh, displaying the images at some constant rate. That is our requirement. So there should not be variation in delay. That is this aspect of jitter. So jitter is again related to delay, but all the frames should have this uniform delay. So the jitter is that aspect. So the first frame has a delay of 10 seconds, second frame has a delay of 13 seconds, third frame has a delay of 17 seconds, and fourth frame a delay of 8 seconds. Then this would affect this such type of application. So that is where this jitter is more important. Now again, bandwidth. Bandwidth is required in general for most of the application, whereas for email, the bandwidth requirement would be less. So for video conferencing and all these things, we need bandwidth, and it may not be important for this email or things like that. So these are the different characteristics of the flow. And QoS, implementing QoS in a network, we will somehow oh, have techniques to implement this quality of service. Now, what are the techniques? Scheduling. So, good scheduling technique would treat different flow in fair and appropriate manner. So, we could have scheduling at the routers. So, it is at the routers that packets for wait for being serviced. Service means that they have to wait in a queue. It should be processed. It should be forwarded. So there, this queue will have various types: first in, first out queuing, priority queuing, weighted fair queuing. So by varying these queuing mechanism or scheduling mechanism, we can implement some quality of service. Now another mechanism is traffic shaping. We have seen traffic, constant bit rate, variable bit rate, the bursty traffic, etc. So we could shape this traffic to some mechanism to control the amount of rate of the traffic sent to the network. So we could implement a leaky bucket algorithm or a token bucket algorithm. So these are certain mechanisms to implement quality of service to shape the traffic. Another is admission control. So here in the general congestion control, I had written admission control. So how mechanism used by a switch or router to accept or reject a flow based on specification, like bandwidth, buffer size, CPU speed, etc., and its previous commitment to other flows. So some other flows, it would have given some guarantee or some commitment. So based on the bandwidth, the buffer size, CPU, speed, etc., it can use a policy for admitting packets. So that's one mechanism. Resource reservation. We won't discuss these things, resource reservation in detail. QoS improved if resources are reserved beforehand. So you have some model called integrated services. You have differentiated services, etc. And in all these models, there would be a connection establishment phase. Some packets should be sent to allocate resources. And such techniques are there. These may not be implemented regularly, but to some extent, some techniques are used. So there are integrated services using resource reservation to improve QoS. There are differentiated services. These are all vast subjects. We will see some few techniques to improve the QoS. Now, this is a FIFO queue. Packets wait in a buffer. So packets are waiting in a buffer. So here this is a router or a switch. Okay. There will be a processor. Some processor would be there in the router or a switch. Now it would process this. Now here we have arrival. Now we need to check initially whether queue is full. If it is full, we should discard that packet. If it is not, if there is some space, we would admit these packets and it would wait in the queue. And there will be some processor in the router and switch. If the arrival rate is higher than the average processing rate, the queue will get filled up and new packets will be discarded. So this is how first in, first out queue. So this is one mechanism of queuing in which you will discard if the buffer is full. First one arrived, first one will go in to the processor. So this is a normal scheduling, first in, first out queue. Then here, this is a bit different. So you have an arrival wherein you would have a classifier. So there should be some mechanisms for intimating the priority. So packets are first assigned to a priority class. So this information should be there in the header, this priority. Each priority class has its own queue. So there are two queues. One is for higher priority and one is for lower priority. Okay. So each priority class has its own queue. The packets in highest priority queue are processed first. So here, in this mechanism, this processor would switch to the other queue when the current one is empty. So this is always looking at this, servicing this higher priority queue, and when this is empty, it will switch on to this lower priority. Packets in lowest priority queue are processed last. So this type of scheduling is called priority scheduling, in which there are two queues, and whenever this buffer is full, we have to discard the extra packet. So these packets are classified into this high priority queue and low priority queue. Now priority queue provides better QoS than first in, first out, because higher priority traffic such as multimedia can reach destination with less delay. So someone has higher priority, they can be accommodated in this queue and they can be processed and sent with lower delay, and something like an email or anything can wait a little longer. So if there's a continuous flow in the high priority queue, packets in the low priority queue will never have a chance to be processed. So these fellows will be starved. If these packets, everything come as high priority queue, there will be starvation for this low priority queue. So this fairness is not implemented in this queue, fairness. So any algorithm should attempt to have sort of fairness. So we go to the next queuing. This is weighted fair queuing. So this is a combination, so wherein you have a classifier and priorities and weights. Okay. This system processes packets at each queue in a round robin fashion. So first from this, next from this, and next from this. So turning switch selects 3 packets. So weight is 3. So first queue. Then it would go to the second queue and take 2 packets from the second queue, and then first packet from the third queue, and the cycle would repeat. So there is some amount of fairness, and the weight is given. So this is weighted fair queue. So number of packets select from each queue based on weight. Example, weights are 3 to 1. 3 packets are processed from first queue, 2 from the second queue, and 1 from the third queue. So this is one mechanism of having queuing with fairness, with weight. So these are the 3 methods for this scheduling: before queuing, priority queuing, and weighted fair queuing. Now we need to look at this traffic shaping. Okay, so here this is an analogy. You have a water flowing into the tap. So this is varying, and if you have a small hole, this is a fixed flow. So rate at which water leaks does not depend on the rate at which input, so unless the bucket is empty. So similar to this is the leaky bucket algorithm. This is implemented in a networking scenario. So use of leaky bucket would shape the traffic. So here a host is sending data 12 Mbps for 2 seconds. Then it is idle. Then it is for 5 seconds it is idle. Then set 2 Mbps for 3 seconds. Now, if we have a leaky bucket algorithm, this should smoothen the traffic or shape the traffic to send out data at a rate of 3 Mbps for 10 seconds. So this is 24 plus 2 into 4, 8, so 6, 3, 6. So it would be 30. It can shape it at 30 for spread over this 10. If you have this algorithm, so how it is implemented? So this is the leaky bucket implementation. So here you would have this thing to check whether it is full, discard. Then you have a queue. A FIFO queue holds the packets. Okay. If traffic consists of fixed size packets, we have seen this ATM network, this asynchronous transfer mode network, there the packets are all of same size in ATM. That's a network. So if packets consist of fixed size packets, the process removes a fixed number of packets from the queue at each tick of the clock. So remove packet at a constant rate. So leaky bucket algorithm is, this is our bucket which is filled with water, so which is filled with packets. Now we are removing at a constant rate, means the hole is fixed. So we will remove packets at a constant rate, means we are removing fixed number of packets. This is applicable if the packets are of same size. However, the packets could be of same size only if the network is an ATM or such type of network. But in general, the packets would be of variable length, because there are many users with a different size and of data requirement and data transmission. And normally the traffic consists of variable length packets. So we cannot remove same amount of packets. So the fixed output rate must be based on the number of bytes or bits. Actually, what is the number of bytes or bits within the packet that should be accounted for? Because normally these packets could be of variable length. Now this is an algorithm for variable length packet. So fixed length is remove a fixed number of packets. Now it is variable length, you would initialize a counter to n when the tick of the clock. So there is a clock. So there is a counter is initialized to n. So we will remove, if n is greater than the size of the packet, send the packet and decrement the counter by the packet size. Say you have n is uh, a value is greater than the size of the packet. So you have put n as 100 and the packet has only a size of 50. Then you can send that packet. Now you should decrement that as remaining 50. Now until all that 100 uh, bytes are sent, we would decrease. Now repeat this step until this n is smaller than the packet. So this is n is reduced and now the packet size is large. We have to again go to initialize a counter to n. So for variable length packets, say we will have a value of bytes to be decreased at every tick. So how many packets can be accommodated? Say if n is 100, it depends on the size of the packet. So when the first packet goes, you decrement that, and when the second packet is 20, 30, and 60, like that, you should decrease until n is smaller than the packet size. Then you repeat this. So this is how variable length packets are handled in this leaky bucket implementation. Whereas for a so that would effectively remove packet at a constant rate. So this is we are making the output at a constant rate, even if we are having a burst traffic at the end. So this is how it is implemented in the network, switches and routers. All the waiting and all these conditions are taking place at the routers or the switches. So there we have this algorithm implemented. So a leaky bucket algorithm shapes bursty traffic into fixed rate traffic by averaging the data rate. It may drop the packets if bucket is full. So what happened if the bucket is full? Bucket is the buffer. If buffer is full, we will discard it. So it may drop packets if bucket is full. Now we have another mechanism which is called token bucket. Say when we implement leaky bucket algorithm, thing is one particular source is not sending any data for some time. So it is not getting credit for that. It is not using the network. So it should be credited for that time for which it is using that which is for which it is not using that time. So only then fairness will be there. So if you want to have a fair algorithm, we need to modify the leaky bucket algorithm so that we have this concept of token. Token bucket allows bursty traffic at a regulated maximum rate. So we'll just see this type of algorithm. This is called token bucket algorithm. So leaky bucket is very restrictive. It does not credit an idle host. So they don't consider a host who is not sending a traffic and for some duration of time, he is not getting any credit. So in that way, this is better. So token bucket is for each tick of a clock, system generates n tokens to bucket. So it is like one token added per tick. So there are tokens put in this bucket. So one token removed and discarded per cell transmitted. So like that, so each tick of clock, system sends n tokens to the bucket. Now when every byte is sent, it will remove one token. So if n equal to 100 and host is idle for 100 ticks. So this bucket collects 10,000 tokens and host can send bursty data later on. So here, those who are idle would get the token. So implementation is token initialized to 0. Each time token is added, counter is incremented by 1. Each time data is sent, counter is decremented by 1. So this algorithm will give chance for those nodes which did not transmit, but they could get this token. So these are the two algorithms which we have for shaping the traffic. One is leaky bucket algorithm, but it does not credit an ideal host. So we would go for a uh, token bucket in which we are putting tokens. So these are the two implementation of this traffic shaping, leaky bucket and token bucket, and these are the queuing algorithms. And in addition, we could have admission control, resource reservation, and this is how quality of service is implemented. So actually, the quality of service is implemented by this mechanism. However, uh, the this is more often discussed than it's an issue that has been discussed more than defined. So here, uh, practically these all things may not be uh, implemented in networking, but provisioning is there. Provisioning is there, so that you could improve the reliability or decrease the delay or make the jitter uniform or increase the bandwidth. So all these are the quality of service, the metric flow characteristics. So this is implemented by these mechanisms. So it is all regarding this quality of service. Actually, I haven't discussed more about this two other mechanisms, which are the integrated services and differentiated services. They are more involved and in which uh, I have mentioned here there is an differentiated service and integrated service in which here there is a mechanism of resource reservation. So QoS can be improved if resources are reserved beforehand. So there would be some packets which are sent by the source. So it will add the quality of service parameters, how much bandwidth, how much buffer. All these are handled at the connection establishment phase. And so in integrated service, this resource reservation is done to improve the quality of service, for which there will be for reservation you would be sending packets. RVSP packets would be sent, and that much of buffers would be allocated and reserved. So this type of mechanism is also provisioned within this networking, integrated services and differentiated services. But we don't implement that normally. So that's regarding the quality of